Welcome to Surds Level 3, one step in a level-by-level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic-by-topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 15 multiplied by the square root of 5. Now to start, we'd like to see if we can simplify either of these surds independently. But because neither 15 nor 5 can be divided by any of the numbers on our square number list, we can't simplify them at the moment. So we can go straight into multiplying. And the way that we multiply two surds together is we just multiply the two numbers within those surds together. So this means that the square root of 15 multiplied by the square root of 5 is the same as the square root of 15 times 5. Now 15 times 5 is 75, so this becomes the square root of 75. A final check to make sure we've simplified is to check whether 75 can be divided by any of the numbers on our list of square numbers. And it can. 75 can be divided by 25, because 75 is equal to 25 times 3. So this means that the square root of 75 can be rewritten as the square root of 25 multiplied by the square root of 3. And because the square root of 25 is 5, this gives us 5 root 3. So 5 root 3 is our final answer to problem 1. In problem 2, we're simplifying 5 root 7 multiplied by 2 root 27. Now we could start by multiplying these together straight away, but it's sometimes useful to see if we can simplify either of the two surds first. Now 7 can't be divided by any of the numbers on our list of square numbers, but 27 can, because 27 can be written as 9 multiplied by 3, and 9 is on our list of square numbers. So this means that the square root of 27 is equal to the square root of 9 times the square root of 3. And because the square root of 9 is 3, this becomes 3 root 3. So the original question becomes 5 root 7 multiplied by 2 times, and the square root of 27 can be rewritten as 3 root 3. So we have 5 root 7 multiplied by, well, 2 times 3 root 3 is 6 root 3. And we can now multiply these two together. So starting with the numbers outside of the surds, we have 5 times 6, which gives us 30. And then looking at our two surds, root 7 times root 3 is the same as the square root of 7 times 3. And 7 times 3 is 21. So this becomes 30 root 21. And because 21 can't be divided by any of the numbers on our square number list, this is simplified. So 30 root 21 is our final answer to problem 2. In problem 3, we're simplifying the square root of 50 times the square root of 50. Now there are different ways of doing this, but the simplest is to understand that when you multiply a surd by itself, the square root part disappears and we're just left with the number that was underneath. So this means that the square root of 50 multiplied by the square root of 50 is just 50. So 50 is our final answer to problem 3. In problem 4, we're simplifying 7 root 18 squared. Now squaring a number means that we're multiplying the number by itself. So we can rewrite this as 7 root 18 multiplied by itself. So multiplied by 7 root 18. Now root 18 can be simplified because 18 can be divided by 9, which is on our list of square numbers. However, because we're multiplying a surd by itself here, it's actually going to be quite straightforward. So we don't need to necessarily simplify, although it would be okay to do that. But multiplying these straight away, and looking at the numbers outside of the surd parts first, we have 7 times 7, which is 49. And root 18 multiplied by root 18 just gives us 18. So to finish this off, we can multiply 49 by 18. And this gives us 882. So 882 is our final answer to problem 4. In problem 5, we're simplifying 2 root 3 minus 4 multiplied by root 27 plus 5. Now here we need to expand the brackets, and if you'd like some more support with expanding brackets in general, please take a look in the top right of the screen now, where you can find a link to my expanding brackets course. Back to this question, what we'd like to do to expand these brackets is to start by multiplying together the first two terms. And we can either do this straight away, or we can first simplify the root 27 because it can be divided by 9, which is a square number, and either approach is fine. I'm going to start by multiplying together straight away. So we have 2 root 3 times root 27, and in front of the root 27 there's a 1. So we can start by doing 2 times 1, which is 2, and then the square root of 3 times the square root of 27 is the same as the square root of 3 times 27. Next we can do 2 root 3 multiplied by 5, and this becomes plus 10 root 3, because 2 times 5 is 10. Next we have minus 4 multiplied by root 27, and that's minus 4 root 27, and finally minus 4 multiplied by 5 gives us minus 20. We're now going to go through each of the terms and see if we can simplify. So looking at the first term, we have 2 times the square root of, and 3 times 7 is 81. So you can put an 81 in there, plus 10 times root 3. Now root 3 can't be divided by any of the numbers on our list of square numbers greater than 1, so this can't be simplified. Next we have minus 4 times the square root of 27, and this can be simplified as we mentioned earlier because 27 can be written as 9 times 3, where 9 is a square number. So the square root of 27 can be written as the square root of 9 times the square root of 3, and because the square root of 9 is 3, this gives us 3 root 3. So minus 4 root 27 becomes minus 4 times 3 root 3, and we have a minus 20 at the end. Now going to continue going through each of these terms and simplifying. So the square root of 81 is just 9 because 81 is a square number. So this becomes 2 times 9. Our 10 root 3 can't be simplified anymore. Next we have minus 4 times 3 root 3, and this becomes minus 12 root 3 because minus 4 times 3 is minus 12, and we have a minus 20 at the end. We can simplify 2 times 9 to give us 18. We have a plus 10 root 3, a minus 12 root 3, and a minus 20 at the end. So now we've simplified each of those terms independently, we can look at whether we can collect some of these together, and we can. We can collect together the 18 and the minus 20, and this gives us minus 2. And we can also collect together the 10 root 3 and the minus 12 root 3. And this gives us minus 2 root 3, because 10 minus 12 is minus 2. So minus 2 root 3 is our final answer to problem 5.